Good evening, children. Welcome back to our class of SAT Math. So we are starting an interesting topic today, that is probability. So children, what actually probability is? Let's understand. So now whenever we do something, so that something whatever we are doing, we call it as sample space. In that there will be certain events. For example, let us say I am tossing a coin. Tossing a coin. So this is an experiment. Tossing a coin is an experiment. When you do this experiment, there will be certain things that happen. So when you toss a coin, what is that it can happen? You can get a head or you can get a tail. So in this sample space, there are two events that can happen. In this, there are two events that can happen. So number of things that can happen in the sample space is n of s, that is equal to 2 if it is this case. Just observe and listen, then we'll work the problems, okay? So let us say you are trying to play a cricket match. So they toss it. So whoever wins the toss, they'll get the chance to decide whether they want batting or bowling or whatever it is, okay? So suppose let's say if I'm a player and I want to first bat, means I need to win the toss. That means if I say head, that becomes the favorable event for me, or the event which I wish to happen. So therefore, that favorable event is denoted by n of e. So that is, when we throw a coin once, we will get only one head. Correct or not? You see how many heads you are finding here? We have tossed a coin, you may get head or you may get tail. So two events happen. So n of s is 2. There be a third event that can happen in this case? No. Therefore, the number of events can happen is only 2 in this experiment. Okay. Now, if I say head is wanted event, this is n of e is 1, means favorable event. So, non-favorable event is what we denoted by n of e bar, which is equal to getting a tail. How many times we are seeing tail? Only once. Therefore, n of e bar also 1. Probability of favorable events or the event which we wish to happen is n of e by n of s. Probability of non-favorable events is, this is n of e by n of s. This is n of e bar by n of s. So, in any case or in any experiment, probability of an event is always less than, probability of an event is always less than 1. Probability of an event not happening is also less than 1 only. Okay? It can be greater than 0 or sometimes equal to 0 also. If there is no chance of that event happening, probability is 0. So therefore, if you take this, P of E means probability of favorable event plus probability of non-favorable events is equal to how much? 1. So if any sample space has a certain number of events and we are talking about happening of all the events independently, sum of all those probabilities should be equal to 1. Okay? This is how we means sum of probabilities is 1, which cannot be greater than 1. Individually, probability of favorable event is less than 1. Probability of non-favorable event is also less than 1. But in any experiment, we have a sample space in which there will be certain number of events that can happen, and from them few of them could be favorable and few of them could be non-favorable. Okay. So this is how we discuss about probability. So this is one basic example I have given you. So let us go for another example, so you get better idea on what we are exactly discussing. So if I talk about throwing a die, if I am talking about throwing a die, so if I throw a die, you may get number 1 or number 2 or number 3 or number 4 or number 5 or number 6. Okay. So n of s is what? 6. I say I want an odd number on the dice. If I throw it once, I may want odd number. So that means n of e. Favorable events are n of e. How many odd numbers we have? 3. Number of non-favorable events is 3 because even number is non-favorable. Therefore, that's 3 again. Right? Let us say the favorable event is multiple of 3. So n of e is what? This is odd. This is even. N of is 3 and 6, 2. Multiple of n of e bar is 4, other than multiple of 3, like that. So whatever he asks is his choice. Rest we have to work out. Okay. Now let us take little higher level. Okay. So now if I say throwing 2 dice at a time. So 2 dice at a time, 2 dice means first die you may get 1, second die you may get 1. First die 1, second die 2. Correct or children? On first die you will get some number and second die also get some number. So whatever possible I am writing here. Okay. 1, 3, 1, 4, 1, 5, 1, 6. 10. Second die has 7 also? No, because every die will have only 6 digits, 6 numbers. So first die we fixed 1. Now we will fix first die as 2. So 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Next we will fix first die as 3. So 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 4, 5, 5 and 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So these are the only possibilities. Look at that children. If 2 dice are thrown, will there be more than this possibilities? No. Therefore, what is n of s? 6 into 6 means for first die, for one die, there are 6 possibilities. 1, 2, 3, 4, 6. And means multiplication. Or means plus. For second die also there are 6 possibilities. N of s equal to 6, that is 36. You see, is it 36 or not? Let's say I want doublet. Doublet means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. This is doublet. Right, children? So that is 6. So what is probability of getting doublet? 6 by 36, that is 6, like that. Right, children? So this is how we work on the probability. So what it is, it depends. See, I have just taken 3 cases and I discussed. But like this, there can be n number of cases, plenty of cases. So we should be able to discuss about all those cases and outcomes. Total outcomes is nothing but the events that can happen in a given sample space, and which I like to happen, which I don't like to happen. Means something happen includes which I like and which I don't like, which I wish or which I don't want to wish to happen, like that. But E is what I wish to happen, E bar is what I don't wish to happen, like that. Otherwise, some of the cases we can also show them by M and N. N of E is shown by M, N of E is shown by M, and N of S is shown by N. So P of shown by P, which is M by N, or otherwise P bar or something like this. Okay. So whatever it is, they are notations otherwise. So therefore, what we show is your choice. But doing it correctly is very, very important. Right, children? So with this basic knowledge, I am starting the discussion. Okay. So it is always a ratio. This ratio is always lesser than 1, but greater than or equal to 0. It cannot be negative, it cannot be greater than 1. Okay. Sum of all probabilities of different events that can happen in a sample space is equal to 1. You cannot more than 1. Sum of all probabilities of events in that sample space is maximum is 1, children. Okay. So if all the events what are occurring does not cover everything, some of the events may not, probability of some of events not be 1 if I am leaving some of the events probabilities. So that's why maximum it should be 1. Sum of probabilities in sample space, if I take sum of probabilities, if I take every possibility, then it is 1. If it is not every possibility, some of events are left, then it is less than 1. Some will be, okay, like that. With this basic thought and basic knowledge, we'll start our discussions, and wherever we need higher level discussions or thinking, we'll go for those concepts. Right? I think this basic thing is enough for us. So look at this. In the figure to the given, the smaller squares has side of length 2 and the larger side square has sides of length 4. If a point is chosen at random from the larger square, what is the probability that it will be from the small square? So now look at this. This is small square, this is large square. So here there is one point taken in the larger square. So that can be outside or inside. That point can be outside the small square or inside the smaller square. He says what is the probability that it will be in the smaller square. Right, children? Applying the probability principle, we get probability is equal to area of smaller square by area of larger square. So what is area of smaller square? 2 square. Area of larger square is 4 square. So that is 4 by 60 is 1 by 4. Right, children? So option A should be the answer. Okay. Please note it fast. Question, then solution quickly. Children, this is given as 4 units and this is given as 2 units. Right, children, go to the next page quickly. We'll go for the next question. Right, children? So let us go to the next question. You see, a hat contains 15 marbles. A hat contains 15 marbles. And each marble is numbered with one and only one of the numbers 1, 2, 3. So 15 hats, there will be 15 numbers. From a group of 15 people, each person selects exactly one marble from the hat. Then he gave some table. Number of people who selected the marble with number are 4, with number 2 are 5, with number 3, 6. Some of them should be 15 because there are 15 people and there are 15 marbles. And how many hats are there? One hat consists of 15 marbles. A hat contains 15 marbles and each marble is numbered from 1 to 3. So 15 marbles will be there on one hat and each of them are numbered with those two. So with number 1, there are 4 people selected with number 1 on the hat. There are 5 people who selected with number 2 and there are 6 people who selected with number 3. Now what is that he is asking? What is the probability that a person selected at random marble numbered 2 or greater? So how many people are there? 2, 5 or greater means plus 6. So 11 people are there with 2 or greater and total number of people are 15. Right, children? So therefore, number of people with marbles 2 or greater equal to 11. 5 plus 6 is 11. Total persons equal to 15. 15, okay. So what is probability of wanted event? Probability of number of people who selected with either this or that is n of E by n, that is 11 by 50. So you have option D, children. Please note it fast, quick. So second page has same thing. Whatever we done in the previous page with ink, same thing is here. So note it with the ink part so that you get everything quickly. Right, children? Have you quit it quickly? Please note the points, main points, so that we go to the next question. Okay, let us see the next question. Yeah. Sarah cannot completely remember her 4-digit ATM PIN number. Means there are 4-digit PIN. 1, 2, 3, 4. 4-digit PIN number. She does remember the first 2 digits. She remembers this number, this number. So 2 numbers she has remembered. She remember the first 2 digits and she knows that each of the last 2 digits is greater than 5. Greater than 5 means 6, 7, 8, 9 and can 0 be there or not? We'll look at it. The 8 will allow her 3 tries before it blocks further access. She randomly guesses the last 2 digits. What is the probability that she get access to her account? So children, we don't know if 0 can be used or not. Because 1 digit can be used. We have 0 to 9. So here some more clarity should be there that a digit, can it be repeated or not repeated? Okay. So now we'll presume that a digit cannot be repeated. We'll presume that a digit cannot be repeated. So, and see if 0 can be included or not. 7, 8, 9. So 0 is not included, children. Means these boxes cannot be filled with 0 and it cannot be filled with a same number which is already used here. So we don't know what are the numbers that have been used. We can only fill with 6, 7, 8, 9. So now uh, see each of the last digit is greater than 5 means we all discussed 6, 7, 8, 9 can be the numbers. Her chance of guessing correctly on the first choice is 1/4 and in the second choice 1/4 means repetition is allowed. Repetition is allowed, children. Means if I 6 here means how many numbers I can fill this box? 4 numbers, 6, 7, 8, 9. Okay. Now repetition is allowed according to the process. He did not mention here. So I've added repetition allowed. Okay, children. If repetition is allowed, let's say 6 has come here. Again 6 can come. So how many numbers are there with me to fill this? Again 4 numbers. Right, children? So probability of filling this box is 1 box out of 4 possibilities, means 1/4, and this is also a number out of 4 numbers that are available. So it is 1/4 into 1/4. Now her chance of getting correctly on both choices, he is talking about only correct number. So is 1/4, only one such possibility will be there. So it is 1/16. So now since she get 3 tries, the total probability is what? First trial, successful. Second trial, she is successful. Third trial, she is successful. So it will be 3/16. So what is that he said in this case? If she randomly guesses the last 2 digits, what is the probability that she will get access to her account? So 3 tries we are taking it as success only. Okay. Either she is successful first time, or she is successful in the second trial, or she is successful in the third trial. Or means what? See, if she is successful in the first trial, she won't go second trial, isn't it? So first trial she is successful, or means if she has failed, it goes to or, then again third goes to or. So this is a question which have become more this one. So I could have first trial she is successful, or first she failed and second she is successful, or first she failed and third she is successful. That is how we usually do. But this is a simple probability. Therefore, we are taking all success cases only. First case she is successful, second case or third case. So therefore, you are getting 3/16. So children, when we go into actual probabilities and higher level, then the discussions will come in a different way. So many missing points here. So this is basic probability. Simple and direct answers should be given to everyone. Okay. Right, children. This is what we need to do. Please note it fast. I think you have followed what we discussed. Please note it and we'll go to the next page. Right, children, let us go to the next page quickly. Right, children, quickly. Right, children, let us go to the next question. Look at this. A jar contains only three types of objects: red, blue and silver paper clips. Probability of selecting a red clip is 1 by 4 and the probability of selecting a blue paper clip is 1 by 6. What is the probability of selecting silver paper clip? So children, I discussed with you sum of all the probabilities in a sample space should be 1, right? So we have 3 events. Sum of these 2 events is we are getting it 5 by 12. So 2 plus third event should be equal to 1. 2 plus third event should be 1. So probability of red plus probability of blue plus probability of silver color is 1. So sum of these 2 we got it as this one 5 by 12. Therefore 5 by 12 plus P of S is 1. So P of S is 1 minus 5 by 12, that is 7 by 12. Right, children? This is in option C. Sum of all probabilities in a sample space, if all the events are this, then sum should be 1. If some event are there, then sum will not be equal to 1. Fourth event is also there, let us say. If I don't add fourth event probability unless it is 0, this will not be equal to 1. So only 3 events are there. So sum of 3 probabilities of 3 events should be 1 compulsorily. Right, children? So then let us go back to the previous page and then from there. Right, children? Please start. Quick. Right, children, let us go to the next page quickly. Quick, children. Right, children? So let's go to the next question so that we understand that also. So a bowl contains 1 marble 0, 1 marble labeled 1 and 1 marble labeled 2 and 1 more marble labeled 3. The bowl contains no other objects. If 2 marbles are drawn randomly without replacement, means first is taken and second is also taken. What is the probability that they'll add up to 3? That will add up to 3. So what all can be 3, 0, 3 if numbered marbles are 0, 3 or 1, 2. These are the possibilities, right? Now, that's all, yeah. Total is 3, he said. 0, 3, 1, 2, right. So now, these combinations can be written like this. You see, first marble can be, how many marbles they have taken out? 2 marbles are drawn. 2 marbles drawn. So first marble can be 0, second marble can be 1. These are the possibilities, isn't it? 2, this one. So only these 2 are the cases where we get 3. Some of them is 3. So you see, first marble 0, second marble 0, 2, 0, 3, like that. Same way I wrote for that die, 2 dice are thrown. So where all you will have 3 sum 1, 2, 3, 4. So total possibility is 4 by, total how many? 3 times 4, 3 into 4. So that is 1 by 3, right, children? Probability of getting as 3. Equal to, that is 1 by 3. So you see, other than these 4 circled ones, are there cases where sum is 3? Children. Therefore, these are the only cases where we can get sum as 3. Therefore, we rounded up, which are 4 in number, divided total possibilities. Total possibilities are 4 is 12. So, therefore, probability is 1 by 3, which is option number D. Right? Please note it fast, quick. Right, children? So, let us go to the next question. A housing subdivision contains only 2 types of homes. Only 2 types of homes. Ranch style homes and town homes. There are twice as many town homes as ranch style homes. So now there are 3 times as many town homes with pools than without pools. Right, children? What is the probability that a home selected at random from the division will be a hometown with a pool? Hometown with a pool. So now look at this, children. First thing is town homes should select first, and then with pools. Right, children? So, and means what? Multiplication. Home from town and with a pool. Okay, children? So now look at this. Since there are twice as many town homes as ranch homes, the probability of selecting a town home is 2 by 3. Why it is 2 by 3? Because if 2 homes are town home, 1 will be for ranch style. So total houses are 3. So 2 are town, 3 are total. So 2 by 3. Right, children? Clear? So next, town homes has 3 times with pools. Okay? If there are X pools, then number of town homes are 3X, like that. So therefore, total will be 4. Denominator will be 4, numerator will be 3. So therefore, probability of a home selected with pools is 3/4. 3/4. So therefore, probability is what? Town home and means multiplication. House with pool. So therefore, 2 by 3 into 3 by 4, which is 1 by 4, children. So option is right, children. Please take it fast. Right, so let us go to the next question. The figure shows a small equilateral triangle inscribed in a large equilateral triangle inside another triangle. So if a point is chosen at random from the large triangle, is the same like first question, children. So area of smaller equilateral triangle by area of larger equilateral triangle. So now look at this. These are midpoints, isn't it? Right? So area of equilateral triangle is root 3 by 4 in side square. 3 by 4 into side square. So side of larger one is 2 times the side of smaller one, because if this is x, this will be 2x. Children, so area of smaller by of larger is 1 by 2, 2 square is 1 by 4. So therefore, following children. Right children, so that is by 4, option C. Right children, this is what we have shown. So this in second page, you can copy it from first page only. Okay. Okay children, let's go to the next question. So now, what is the probability of getting at least 1/6 when you roll 2 dice? When you roll 2 dice. Children, this already we have discussed. So again, let us see what it is. See, these are the probabilities of first 6, 1 by 6. Second die 6 is 1 by 6, like that. So that it says when the probability of getting at least once when 2 dice are rolled. So first we are getting 6 and second die also we are getting 6. So and means multiplication. Otherwise, first die may be 6 and second die may not be 6. Which is 6 means 5 by 6 or not. If 6 is 1, not 6 is 5. 1, 2, 3, 4, 5. So therefore, 5 by 6 is the probability. So product is, the probability is first die and second die not 6, and means multiplication. This is the third case. First case is not 6, but second case is, second dice is, or second time it is 6. So 5 by 6 by 6. Both may not be 6. So 5 by 6 into by 6. Okay, this is 5 by 6. But he said, what is the probability of getting at least 1/6, minimum 1/6? That means only these three or not. There is no 6 here. So it does not come what he asked. So therefore it should be 1 by 6, 1 by 36 plus 5 by 36 plus 5 by 36. So which is 11 by 36. Right children? First case may happen, means both may be 6s, or plus first is and second is not 6, this is the case, or plus, or means plus and multiplication. First is not 6, second is 6, like that. So therefore this is the positive. So let us go to page 1 and start here children, quick. So let's go to the second page, quick children. Right, so let us go to the next question. Please fast. The test grades of 26 students in a math class are shown in the chart below. So I need to show the chart. If a student is chosen at random, which of the following is closest to the probability that student scored more than 82 on the test? More than 82 means what? These three. So probability is what? 10 plus 3 plus 1, that is 14 by total. So 14 plus 7, 21 plus 5, 26. 14 by 26 is probability, which is 0.5. So answer is this. This sum of these three by total. Children, that is 10 plus 3 plus 1 by 5 plus 7 plus 10 plus 3 plus 1. So that is 14 by, this is 26. Right? Please note it fast, quick. Right, so let us go to the next question. Question 2 to 3 refer to the following information. 73 children from the United States aged 6 through 11, 6 to 11, were tested to see if they were overweight. The data shown in the table like this. 6 to 8 age groups, 31 are found to be overweight and 26 not overweighted. 317 are the total. Ages 9 to 11, this many overweight and this many not overweight and this many are total. So now total number of students overall, if you take immaterial of the age group, it is total 194 are overweight and 549 are not overweight. Total tested people are 743. Now you should see whether he is talking about overall or only ages between age group 618 and 9 or what it is, we don't know. So let us see what is question. So according to the table, what is the probability that a randomly selected 9-11-year-old is overweight? So 9-11 years, how many are overweight? 163, but total is 476. So 163 by 426. 163 by 428. Okay. So much of this thing. Instead of letter, I will close it here. So 163 by total is what? That much time is not needed. Simply you can write 163, 426. Right, children? So this is, I don't know which number, which value get it. Divide it and get that, children. This is probability of overweight between 9 to 11 age group. Right, children? So that is 163 by 46. Directly write it. This much explanation is not needed. You can directly write it. Fast, quick, children. I don't know what is the answer. Just let us check the value instead of we dividing it A. So this is 0.38. Quick, children. Directly 2 lines only. Question, 2 lines answer. Not all this. Explanation I told very clearly. Between 9 to 11 years group, who overweight is 163 he gave, and total in the right side 426. So 163 by 426. Direct simplification. Okay, children, finished. Let us go to the next question. This is all same. Yeah, according to the table, what probability that the randomly selected overweight child ages between 6 to 11 means total he is asking. 6 to 11 less than 9 years old. What is this less than 9 years old? 6 to 11 less than 9 years. 6 to 8 he is asking. 6 to 8. So what are there between 6 to 8? 31 overweight by 317. 31 overweight by 317. You see 13 overweight by 317, or otherwise 1 minus that 0.38. 1 minus 0.38, or otherwise 37 by 31. 31 by 370. 194. What 194? Is it 194? He is talking about only comparative to this, not overall strength. So 31 divided by 194. 31 divided by 190 children. So that is equal to 31 divided by 194. So that is equal to what? So answer 0.159. So option A. Please note it, children, quick. So right, children, let us go to the next question. The data in the table below categorizes the GPAs of the students from two high schools. School A, School B, less than 2.5, all this data given. Less than 2.5 are 222, less than 3.5 are 117, between 2.5 and 3.5, not below 3.5. Greater than 3.5 are 36, total 425 students. Similarly, School B, this is the data. Now let us see what he is asking. A student with GPA between 2.5 and 3.5 is chosen at random. What is the probability that the students goes to School B? So School B is like, if you take the total students in this is 425. Between this is 425. School B 308. School B 308. Total is 425. So if you go back, you will get answer as 308 by 425. So option is 0.724 or 725, because nearest value we have rounded up. That's all. Okay, children. So this is the case. Please note it fast. Go to the next question. Okay, children, let's go to the next question. The data in the table below categorizes GPAs of students from two high schools. 2.5, this is what it is. Yeah, same data, but numbers might have changed. Numbers are also same. So the question has changed. If the student from school A is chosen at random, what is the probability that this student has a GPA 2.5 at least? At least means minimum. Minimum 2.5, he says. So what is that as? Yeah. So minimum 2.5. So this is 2.5 and up 117. Less than 2. We should remove. minimum 2.5 means 117 plus 36 by 425 because only school A he talked, he did not talk about school B or between A and B comparison like that. So school A with at least 2.5 means minimum 2.5 means either between 2.5 and 3.5 or greater than 3.5. So or plus by total in school A are 25. So right children, so that is the ratio you need to take. So 117 plus 36 by 25 which is 0.36. Right children, please note it fast, quick. Right children, so let's go to the next question. The incomplete table below classifies the number of students by height for the 12th grade students at Washington High School. There are twice as many male students that are less than 6 feet tall as there are male students that are at least 6 feet tall, and there are 4 times as many female students that are less than 6 feet tall as. So many questions are too many. So let us look at this. I don't know, there is something missing. Achha, this data he gave which we are okay. So now this is the table. Now what is that? The incomplete table below classifies number of students by height for the 12th grade. Incomplete he said, that's why it is blank children, okay. Grade students at Washington High School. There are twice as many male students, male, female. There are twice as many male students that are less than 6 feet tall. Less than 6 feet tall. So now that means if we take this as x, then it should be 2x. Female be 2x. Okay. And there are 4 times as many female students that are less than 6 feet tall. One is less than and other is at least. So this is x, this is 2x, and if this is x, this is 4x. Okay. So this is what. Let us see the question, children. There are twice as many male students that are less than 6 feet as there are males that are at least 6 feet. Achha, achha, okay, okay. So the comparison is only between male and only between female. So there are twice as many male students that are less than 6 feet than 6 feet tall, less than 6 feet as there are male students that are at least 6 feet. So x and 2x, and if it y as y, it should be 2y. Okay, children. So if this is x, this will be 2x. If this is y, this will be 2y. So x plus y is 15. 2x plus 2y is 34. So it should be 4x because he said 4 times, no? 4 times, yeah. This is 4y. Right, children? So x plus y is 15. 2 into x plus 2y equal to 34. So x plus 2y equal to 17. So if you take this, x 2y is this one. So y is 1. So this minus this, if you take 2y minus y is y, that is 17 minus 15 is 2. If y is 2, x is 15 minus 2, 13. Right, children? So this is what we need to work on. So now, what is that he asked? This is all okay, children. We have already done it. This is okay. So what is that he asked? Find the probability that randomly selected student that is at least feet tall is female. So female only we should talk. at least 6 feet tall is female is Y by total it is 5Y. So total it is Y and female is Y and total at least 6 feet is 15. So Y 15. So Y by 15 means 2 by 15. Y is 2, 2 by 15. That is equal to 0.133, right? So please copy it from here. So 0.133, where are ABCD options? 2 by 15. 2 by 15 is this. Right, children? Please note it fast, quick. So probability he is asking you to find out of female who is being this. So these two I should take, children, okay? Right, children, so let's go to the next page. This solution is not needed, we have already done there, but if you want, you can take it, not noted there. So please note it fast. Okay, children, we will go to the next question. In the figure, ABCD is a square, the triangle is isosceles, EB is 10 minus 2C, and AD is 10. So let's look at the diagram first. Yeah. So this is isosceles triangle. So EB is 10 minus 2C. AD is 10. So this should be 2C. So this is also 2C. Right? So now what is that he said? A point square ABCD is chosen at random if the probability that the point will be in shaded region. Means same like previous questions. Area of this triangle, area of square. So this is 10 minus 2C. So this should be, EB is 10 minus 2C. So this should be 10 minus 2C, children. So this should be 2C. Okay. So this is what we need to know. Area of triangle by area of square. So look at that. AE is 10 minus 2C, that is equal to 2C said. Area of triangle is half into base into height. Half into base into height, which is 2C square. Base is 2C, height is 2, so which is 2C square. Now area of square is what? Side into side. 10 into 10 is 100. So it is area of triangle by area of square. So which is C square by 50. So again, we are given that this is equal to 2 by 5. Did he get 2 by 5? Yes, 2 by 5 he gave. So this C square by 50 is 2 by 5. So C square equal to 4. So C equal to 2. Right, children? Please note it fast, quick. Okay, children, I think you have copied it. So hope you have understood it well. Generally, probability is a dry topic, but it's good that you have all simple problems. We are not entered into the actual probability which are in intermediate second year, but these are all very basic, so you should be able to enjoy these things because they are really practically related things. They are not something theoretical, so practically related, so you can guess, realize, analyze and then answer. Okay, So wish you all best of luck. We'll meet in the next class. Thank you. And you have an exam maybe on Sunday. So write well. Anyway, tomorrow we have classes, but still write well and have a great day. Thank you.